Well, here at the Virtual Music Education Conference, we seek out to bring you the very best in our field. Now, as educators, we need to know the most recent research to back up why and how we teach. And I believe we've got our next speaker who's at the forefront of this field. Now, her name is Dr. Nina Kraus, and the number of published research papers that she has been involved with in this area is just truly outstanding. If you're interested in reading academic research papers, then I can highly recommend her website as an amazing resource. Now, Dr. Kraus is a neuroscientist and she studies this every single day. So she really is the person who can actually answer questions and tell us what the research is really saying. So I look forward to finding out her insights today. Thank you so much for joining us, Dr. Kraus, and sharing your wealth of information and knowledge and experience with us in this area today.
Well, thank you for having me.
It's going to be a pleasure, and I know we're going to get a lot of insights out of this. Dr. Kraus, can you start off by just giving us a little bit of background information about you? If music teachers we're speaking with today and haven't heard about you before, how is it that you got started in this area of neuroscience, and how is it that you became so passionate about the area of music in the brain, and why is it so important to you?
Well, so I'm a biologist, and I studied learning through sound. And sound has always been important to me. And, you certainly know all about sound, and more than most people do. I mean, sound is invisible, but it is one of the most powerful forces that exists, that it's absolutely central to human communication through language and through music. And, many of the world's most powerful forces are invisible, like electricity and magnetism. But so I grew up in a family of, my mother was a musician, and also we spoke a couple of languages at home. And so, sound was always a way in which communication and information happened for me. And I, when I first went to the university, I thought I would study literature, comparative literature, because I spoke some languages and I like to read. So I did that just starting out. And then I took some biology classes and realized that I really loved the biology. And I discovered a book called Biological Foundations of Language by someone called Lenberg. And I thought, well, gee, that's interesting, Biological Foundations of Language. And so, I first began really studying how sound is processed in the brain, and ways in which the link to humans was more initially through language and learning, and more recently I've gone off into music as a very large direction for our lab. But so you can think, so in our lab, in the Auditory Neuroscience lab here at Northwestern University, very, very close to Chicago, we study how our life in sound changes the brain. And when I first began studying the biology of learning, I was actually recording from individual neurons, individual cells in the brains of rabbits and guinea pigs, and really looking firsthand at how the nervous system changed when a sound had a meaning for an animal. So, if you would teach an animal that a particular sound signaled that food was going to happen, initially the response to that sound would be a particular response of that cell, but once it had meaning, the response to that same sound changed.
Mm.
And so, we could really see this firsthand. So one way of thinking about what we do is we study the biology of learning. But of course, we are really interested in taking this knowledge and applying it to our understanding of human language and human communication and learning through music.
Mm.
So if you think that so we study the biology of learning and the way in which different forms of experience, so the experience can be enriching. So we can speak a number of languages,
Mm-hmm.
or we can play a musical instrument. We can also experience deprivation, disorder, decline that happens through sound. So, for example, as we get older, we often have more difficulty than usual, hearing people's voices in a noisy place.
Mm-hmm.
So hearing a noise becomes harder. Throughout development, children often experience language disorders, difficulty reading,
Yeah.
for example, and you don't think right away that reading happens there's a connection through sound, but there is, and we've known for years that children who have difficulty with language often have difficulty processing sound.
Mm.
So we've been really interested in understanding what goes awry there.
Mm.
Other forms of deprivation are linguistic deprivation. So, a child who maybe is born in poverty, there are data indicating that often maternal education is linked with how many words a child might hear within a given day. And so again, it's a matter of making sound to meaning connections. And what we've been able to do, and again, this is where my lab fits in, is that sound is a signal. And so sound waves are signals, and brain responses, brain waves, are signals too. So as I'm talking to you now, the nerves in your brain that respond to sound are producing electricity,
Mm-hmm.
and we can measure that electricity. So the electricity is the currency of the nervous system, and we can measure that and see how good a job your brain is doing at processing sound based on the experience that you have had in your life with sound.
Mm.
So if you speak multiple languages, or if you play a musical instrument, these really do influence the kind of response that we could be measuring from your brain right now.
Mm. It's fascinating, Nina. I mean, uh, there's so much just in that section there especially for us non-science background people. Just give us a little bit of a picture. We can find out what a good job our brain is doing by hearing the sounds. How do you see that?
Great question. So we put electrodes on the head, just on the scalp. And when we do this on little kids, because we have projects with 2 and 3 year olds, we call them buttons.
Mm-hmm.
So we put buttons on the head, and these sensors pick up the electricity that happens. It occurs whenever you hear a sound.
Mm.
So these are very, very, very tiny signals that we pick up from the brain, so we have to amplify them many, many thousands of times.
Yeah.
But so for example, if you look at the home page of our website, right in the middle of the home page is a little icon, and it says "Our Biological Approach." And I encourage everyone to take the time. It's 2 or 3 minutes long.
Mm-hmm.
It's a little movie, and you should have the sound on your computer.
Mm-hmm.
The sound doesn't happen right away. First it's quiet, and then eventually you will hear the sound waves that are played. So usually it's speech and music are the sounds that we play.
Mm-hmm.
And then you can actually hear the way in which the brain listens.
Mm-hmm.
So our approach is one that we are able to, with such precision, pick up how the brain responds to a sound that the electricity that we pick up when you play it out through a speaker actually resembles the sound wave.
Mm.
So you'll hear that, and you'll see it too. I mean, this is where we first got the idea of playing the brain waves out through our speakers, because we looked at them and we saw, oh, this looks very similar to the sound wave. We ought to be able, in the same way as I can take my electric guitar and play amplify an electrical signal. You can take any electrical signal, like the response you get from the brain, and play it out through a speaker and sonify it, So that gives us a lot to work with, because, think about, you all know about sound consisting of components like pitch and timbre. And
that's our language.
timing,
Yes.
right?
That's right.
So and what's marvelous about our hearing system is how fast our hearing system works. It's much faster than vision, for example, because the sounds of the crash of a cymbal, of a drum, or the attack of a string, or of a note on the piano, that happens very, very quickly. Also, the sounds that distinguish one consonant from another, like B and B, these sound waves happen very, very quickly, and our brain has to process those sounds very, very quickly. And we can measure how good a job your brain does at processing all of these ingredients of sound. And, jumping ahead, what I can tell you is that playing a musical instrument strengthens the brain's ability to process sound in a way that is important, not only for processing musical sounds, but there is tremendous overlap with the system and the biology that processes sounds of all kinds. So whether it's a baby crying or it's language, speech sounds, the brain that automatically learns to process sounds with great precision with respect to timing, so microsecond timing, pitch, changes in pitch, and timbre, is a brain that is now able to deal with the signals in the world that are so important for communication with tremendous strength automatically. So you know how when you do something again and again and again and again,
yes,
so in this, it's like you learn to drive a car or to ride a bike, you don't have to think about it anymore. And in the same way, once you make sound to meaning connections, in the same way as some research that really got me interested in this line of work in the first place was some research that had shown that the people who speak tonal languages, like Mandarin,
yes,
there are some sounds, some changes in frequency that happen within a syllable, which is just not something that these excuse me, these changes aren't quite as complicated in non-tonal languages. But what these scientists found is that if you speak a tonal language, even if you're asleep, your brain is really, really good at automatically processing all those sound details that you need for your language. And so, that really shows us that if you do something again and again, that's why I like to say biologically we are what we do. Our past shapes our present, because what we do many, many, many times in the past makes it so that now in the present you are processing sounds in certain ways quite automatically, and you can use that to your advantage.
Wow, Nina, that's fascinating. So the saying, repetition is the mother of skill is actually not a myth. It is actually true.
It's very true. Yeah. And so the work that I was just talking about with language, this is work that was done by a scientist at Purdue whose name is Ravi Krishnan. Someone who has studied repetition and the role of repetition is, I don't know if you might have heard of Ani Patel, but he has what is called the opera hypothesis, that where he uses this to explain why it is that playing music might strengthen language skills. And so the O in opera stands for overlap. So there's overlap in the sound, and in some of the brain processes that happen for both language and music. So that's O. P is precision. And as musicians, you know that any tiny change in timing or in pitch really changes the musicality of a piece. So the precision required for processing sound in music is higher than generally for language. I mean, now you're listening to my voice over a telephone, and the information. We tolerate a degraded signal for speech. And we can still understand if somebody speaks with a foreign accent, or if you're in a car and it's noisy. So there are many, many redundancies in speech, but music really requires tremendous precision. And so if you sculpt that precision and shape that precision for your brain, for music, it will then cascade and transfer to language. So that's OPE, stands for emotion. And again, from a neuroscience perspective, we know that we learn what we care about. And in very we know that just anecdotally, but in very controlled experiments with, you can train animals to do all kinds of tasks through sound. And if at the same time you're stimulating the emotional areas of the brain, the animal will learn faster and will remember longer if the emotional system is engaged. And of course, music often engages our emotional system, so that helps us learn. So OPER, here it is, I finally got to it, repetition. So you have to do things again and again and again and again in order for your nervous system to turn it into something automatic. And finally is the A for attention. And that is that you have to learn what to pay attention to. And, an example that I like to give is, so I play some guitar, and my husband is a musician. And a little while ago, I was just trying to play a lead that I was listening to Dire Straits they were playing.
Mm-hmm.
And as I was trying to play that, kind of do what McLaughlin was doing, he came by and he said, he is not using his pick there.
Mm-hmm.
He is just simply, lifting the fingers off the strings of the left hand, and the sound, the very, very fast notes that you're hearing are simply that.
Yes.
And before, of course, that's very common to you. You know that.
Yeah.
But to me, before he pointed that out, I was deaf to that. But once he taught me what to pay attention to, now every time I hear that, I can recognize, oh yeah, this is what I need to do. But you need to learn what to pay attention to, and music really helps you pay a lot of very, very careful attention to sound that has meanings, like the example I just gave you.
That's incredible. That's something I haven't heard explained to me so well before.
Well, I think what is very exciting to me is to take something as complicated as learning and language and music and to look at it through the lens of signals, which to me are very comforting because, a signal is objective. And, 1 and 1 is 2 today, and 1 and 1 is going to be 2 tomorrow. And you can count on these things to try to get a handle on, such complicated ideas, such as learning through sound.
Yeah.
And it's truly remarkable to see how one's experience in sound, for better and for worse, shapes one's brain for communication. So biologically, one's response to sound really depends on the experience that you have with sound throughout your life.
Just a fascinating
insight. So it's very important for a music teacher, right?
It certainly is. It's imperative that we know this, isn't it? And thank you to you, Nina, and your team. You've made it so easy for us to see the way that you set up these, I suppose we would call them experiments, but the way that you set up your research, and it's so easy to see what you mean by the sound waves needing to pattern the brain waves in some way. That's how I would say it as a non-scientist, but I mean, I'm sure you've got different terms for it than that, but that's what it appears like, and using those fundamental sounds.
Yeah, no, that's exactly right. So getting back to you asked me, well, how did I get into this? And so I'm a biologist and I study the biology of learning.
Yes.
And it turns out that music it's cool just because it's music and wonderful, but music is a marvelous model for learning. And so, why is this? And that is because in order to learn, so this is a framework that that we've developed in our lab, and if one is interested, you can download this particular publication, and it has to do with learning through sound involving cognitive, sensory motor, and reward circuitry.
Okay.
So, sound has to come in to the ear and enter the brain, and the brain is connected, obviously, to the centers in that are important for memory.
Yes.
That are important for attention, and that are important for emotion, and for movement. So this interaction between sensory, motor, cognitive, and reward systems, that is at the it's the foundation of learning. Having all of these ingredients of the nervous system engaged is what enables us to learn effectively. And music really engages our cognitive, our sensory, our motor, and our reward systems remarkably well. So it turns out that music is a wonderful model for studying learning. And, we want to study learning and the biology of learning because we want to know how can we learn to become better musicians, how can we learn our languages better, and how can we discover when people have difficulty processing sound and maybe have language impairments, any kind of difficulty in the processing of sound. So this is part of what motivates our work.
So Nina, what you're finding is through science, you're finding that actually music shapes the brain to help us become better learners. Is that what you're saying?
Yes.
Fantastic. Wow. And so that is not myth. That is actually what you're finding even in the latest research you've got. I mean, I've looked through your research papers, and I think even this year, there's at least 10 there. It can all be a little bit overwhelming if it's all new to you. But what sort of studies have you been taking place with you lately, and what are your latest findings, your very latest ones?
Well, so we have done a number of cross-sectional studies. So that means that we've looked across the lifespan at preschool kids, school-age kids, young adults, and older adults, and have looked at how music experience influences the processing of sound. And so one of the things that we have found, both in how people tell us what they hear and what their brains tell us how they hear, is that people who play a musical instrument and actively play a musical instrument are better at hearing speech in noise. So, in a noisy classroom or a playground or a restaurant, the world is noisy, and we need to be able to make sense of sound.
Okay.
And if you play a musical instrument, it turns out that you're quite better. You tend to be better at hearing speech that is presented in a challenging acoustic environment. And what is, again, very beautiful is that you can see this in the brain's response in an individual. So you can see that the brain responds to a sound in quiet, and then you add the noise, background noise, maybe a lot of other people talking all at once. And the response in someone who does not play a musical instrument, the response to speech becomes really quite degraded, whereas the signal that the musician is listening for is much more robust and much more resilient to the degrading effects of the background noise.
Wow, that's amazing. So it does shape our brain for the better.
Yeah.
Wow. And does that mean?
So,
and that's just listening to music. That.
No.
No. Okay, that's playing.
Playing.
Aha.
And I like to say you are not going to get strong. You're not going to become physically fit watching sports.
Yeah.
You have to do it.
Yeah. Yeah.
At least for the kinds of fundamental automatic changes that I'm talking about here. the ability of the brain to automatically process sound more efficiently and noise. And importantly, so there are a number of ways in which we need to process sound for language. Generally, in our study, we talk about people who are regularly playing music, to the extent of even playing a minimum of 20 minutes twice a week. But just regularly engage with playing a musical instrument. So these are not these are hobbyists.
So the key words are here that it's got to be regular. And it's not like we're working up to athletic level where, if you were working out for the Olympics, you would be doing it obviously many, many hours a day. It's 20 minutes 2 times a week, and that's still got an impact. Is that right?
That's exactly right.
Wow. That's incredible.
That's exactly right.
So
yeah.
Yeah, so obviously your stance on that is that obviously music is important in our lives and it is important for our brain, and therefore what does that lead us to then, Nina? What?
Well, I think that the connection is the science is really showing that actively making music strengthens the brain for processing sound, for any kind of sound, whether it is language or music, and it strengthens the brain for communication in sound. So, I started out saying, okay, so we've done these cross-sectional studies across the lifespan, but also we have studies. So again, I really encourage people to go to our website and look at our, if you click on the panel that says music, and also there's a panel that says neuroeducation.
Yes.
But for each one of these, we have what we call our friendly overview slideshows, which is just a couple of pictures and one line of text that summarizes a study that we did. And so if you just want to know, you just want the punchline.
Yeah,
just
fantastic.
look through the slideshows. That's all you have to do. If you want the details, you can download the actual study. But often you just want to know, what is the story overall? You want a broad picture.
Yeah. So as teachers, we just want a few facts, that we can tell our students about, and use it as what we would say, I suppose, core education, I suppose.
Yes, and so the teachers in particular, a page that is especially there for teachers is neuroeducation, and so that's where we have done longitudinal studies, so not cross-sectional, but longitudinal, which means that you follow the same child for a number of years.
Yes, that's
as they go through their music training, and you see how their brain may or may not become strengthened for processing sound. And so we have done a number of these studies in Chicago public schools and in Los Angeles. And again, good summaries of those projects are in our overview slideshow under neuroeducation. On that neuroeducation page on the upper right, there is we call it, it's a summary paragraph or summary page that just summarizes our findings on a single page with the references there if you want to go any deeper. And what we've really been able to discover is that children who, because when you do a cross-sectional study, you never know, maybe for everyone, the role that genetics and plays is important, and people come to music and to everything else with different genetic proclivities.
Mm. Mm.
Um, so it's harder to disentangle those cross-sectionally, whereas longitudinally, if you have a group of kids who are performing similarly and have brain responses that are really very similar before they start playing music, and then you have one group who plays music and another group who does something else.
Mm.
You're really able to follow the children over time and determine that it is actually the act of playing music that seems to strengthen the brain for sound.
As music teachers, Nina, I think there's something on the tip of all of our tongues. Is Nina, you've said that it takes 20 minutes of practice 2 times a week for you to get the benefits of better learning through music and via music, if you like, and better learning overall. But how about this question of singing versus playing? Which is better there? Is it better to play an instrument, or how about singing? Because especially in our elementary schools, I mean, singing is fundamental.
Right, right. Well, we've are actually doing some studies comparing people who play different instruments, and what we are finding is that it in terms of these fundamental ways in which the nervous system changes, it really doesn't matter which instrument one is playing. There are some specializations where, for example, if you play, drummers, for example, are really especially able to pick up on the rhythms of language that makes it easier to pick up on, rhythmic elements of sound that help you make sense of sound. But the point is really that each instrument has its own specializations, but in general, to tune up the brain for processing sounds in a way that is important for processing speech and language really seems to occur irrespective of the instrument played and irrespective of the genre of music.
Okay, so it doesn't really matter if we're singing in a choir or playing in a band. It's the same benefit. But specializing in certain areas.
Fundamentally, yes.
Okay.
Fundamentally, yes. There are.
I mean, there's a lot of exceptions, I suppose. Yeah.
Well, yeah, there certainly, like, for example, if you play the piano, your brain is especially tuned to the sound of and the nuances of piano notes.
Yeah.
In the same way as your brain is tuned to the sound of the language you speak.
Yes.
Right?
Yeah.
But still some of the benefits that have to do with processing sound for language, for hearing language and speech and noise, for remembering sounds, these are these happen across instruments and across genres.
Well, that's thank you for sharing that with us, Nina. That's fascinating. And Nina, I know that as music educators, we're always looking for new ways of advocating for music. We have to be, in some ways, even if as teachers, we're out there almost having to say the benefits to our schools, or even sometimes feel like we're selling it to parents constantly. What sort of things, with this knowledge in mind and this research in mind, what should we say about music and its benefits to people, without getting ourselves into hot water, so to speak? And one or two easy to understand concepts that we can get across to people in just a few minutes as to why people should learn music ahead of other subjects, perhaps.
Yeah. Well, I mean, this is where the science comes in, because on the one hand, you can believe in certain things and you can have anecdotal findings, or you can have science. I mean, the currency, as I said before, the currency of the brain, of the nervous system, is electricity. But the currency of science is publications in peer-reviewed, the world's best journals. And so, because it is important for teachers, for example, to advocate for what they think is important, in other words, music education, knowledge is empowering. And so I just cannot overestimate and overstate how important it is if teachers really want to advocate for music, spend some time on our website and have the studies and the outcomes of those studies right at your fingertips, so that you can direct people and show how adding music to a curriculum can actually strengthen the nervous system for all kinds of other forms of learning, especially other forms of learning through sound. So, educationally, we're always, of course, needing to develop language skills.
Yes.
And it would seem that music is playing a musical instrument strengthens the development of language skills. But if you go to our website and you look at the slideshows and you look at the articles and you can point to look at the study. The study shows that children who were engaged in music education for a number of years were better able to strengthen their reading skills, for example. That their brain's automatic response to sound is simply a more robust and stronger one, so that making sense of sound, which is so much part of our daily lives, is facilitated and strengthened. So, the website is, it's there because of the question that you just asked me.
Yes, yes.
It's a labor of love because, to me, some of the most important correspondence that I get from people is from a teacher, say, who says, thank you for publishing this paper. I was able to take it to my principal, my superintendent, and it was helpful in our efforts to convince the school board to advocate for more resources towards music.
Fantastic. And obviously, I mean, principals and admin staff and so forth, and communities even will listen to the facts when it's scientific research that is based on that fact. That you can't deny that, can you?
Well, this is what the science can help us with. And so, for example, I've gone to Washington and to Capitol Hill, and that there are a number of senators and congressmen who are interested in what they call STEM to STEAM, which is adding the arts into the teaching of math and engineering and the sciences. And so adding this A, the arts, and especially music education, it is easy for me to be able to say, look, here is scientific evidence that supports your political position here for education. And so I think that any teacher should be able to use these resources and use them to strengthen music education in our society.
Well, this has been fascinating. It's a very short insight, but it feels like it's taken minutes here, Nina, and I think this is a beginning for so many teachers out there who are, some of us feel, even though we're surrounded by people, we feel isolated in some ways and feel away from this kind of information. But you managing to bring this to us in a very, even though you've got this such a scientific background and you're working this every day, you've managed to make it understandable to us. And that's something that we can really appreciate, and just that beautiful resource that you've got online. What can you just tell us what that resource is, what that website is, so that people can get straight to it?
Absolutely. And so, if you look, look for Brain Volts, BrainVolts, Brain Volts, or my name will also take you there. But the actual site is www.brainvolts.northwestern.edu.
Beautiful.
So that's www.brainvolts.northwestern.edu. And BrainVolts is BrainVolts, all one word.
Fantastic. And I've been to that website many times, and I just find it an invaluable resource to any music teacher. So I would highly recommend that to anyone listening today. And if you haven't seen Nina and her team's website there, it really is it's a go-to place. I really feel that you guys are on the forefront of this technology and this research, and it's really accessible. So fantastic.
Good.
Nina, let's just find out, just before you go, what are your next plans? I mean, if you're far too young for this, you're far too young for legacies and so forth. You've got so much more in your life to come, I'm sure. I don't know. But what is it that you would like to achieve with this in your lifetime, and in order to better understand the brain and the music? And what are some of the questions that you're going to be exploring in the future?
Yeah. Well, so knowledge is empowering, right?
Yeah, that's a great belief we should all have.
So really, so I mean that is what we try to do. We want to communicate our findings through our website, and we have actually a lot of videos as well of lectures and such. But we have so much to learn.
Yes.
And I think music can teach us a lot about the brain, and then the brain can teach us a lot about music. And one of the things that we are working on is to create. I mean, right now the technology needed to record these brain responses is expensive, and it's rather complicated.
Yes.
And so we're working to develop a cost-effective and affordable and user-friendly way to measure sound processing in the brain, because we would like to be able to study thousands of kids who are experiencing different educational curricula, different experiences, different backgrounds, and we are also interested tremendously. I mean, any teacher knows so clearly about individual differences, and so each child is different, and our technology is one that really arbitrates. We can really it's really meaningful in individual people. And so what we're really hoping to do is to create a technology which is based on this physiologic response that we measure. By the way, we call it FFR, following response.
Sorry, Nina, could you just say that one again? We just broke up in that word.
It's FFR. It stands for frequency following response. So those are just three letters, FFR. And it's really the brain's ability to follow the frequencies and all the changes in frequencies that happen over time, which is really what sound waves are. So it's the brain's ability, and as scientists, it's our ability to extract that information from the nervous system. So what I'm hoping that we will be able to accomplish is to, for any teacher who wants to study and wants to be informed more about their educational practice and the influence that it has on the nervous system. I would like to make this have this technology be readily available.
Well, that's going to be a great help to the whole world, really, isn't it? And these simple tests are just going to help us diagnose not just abilities, I guess, but also learning conditions later on. Is that right?
That's right, right.
That's amazing.
And monitor, monitor progress and change and
Yes.
learning.
So better tracking.
Uh,
So better tracking for monitoring progress and learning, and much more factual tracking.
right. So I hope we can do this, and it's actually quite a it's a challenge.
Yes, but it's a huge step forward. And oh my goodness, Nina, we so appreciate you immersing your whole life into this with your team, and appreciate that you can take something as complicated as how the brain works when it's immersed in music and make it simple enough for understand. So as a group of teachers, we can better educate our students and help our communities understand its need. So thank you so much for your time, Nina. We so much appreciate this time to talk to you.
My pleasure.